right, so welcome back to our discussion about the analysis of graphs and the attributes of functions. And this is the last video in this series. And in this video, we're going to talk about how do we evaluate the difference quotient for a given function. So let's jump in. Okay, so what the heck is a difference quotient? All right, so there are several different types of difference quotients, but there's one in particular that you're going to use an awful lot, especially as you move into calculus. And that is what you'll find right here. Now, why is it called the difference quotient? And that's pretty evident if you look at what's going on. In the numerator, you have a difference, but you have a fraction, which means you're dividing by h, which means you also have a quotient. So, in order to evaluate this for a given function, there are three main steps, and keep in mind that when you do this, you will always be given a specific function to be working with. So let's look at the three steps. The first thing you're going to want to do is, from the given function, you will want to evaluate f of x plus h. That means we're going to sub in x plus h everywhere we see x, and simplify. The next thing you're going to do is, once you have found f of x plus h, you're going to subtract your given function from it. So f of x plus h minus f of x. Notice that that is the numerator piece of the difference quotient, or the difference in the difference quotient. Okay? One thing you need to remember is that you are subtracting the entire function, so you are going to want to make sure that you use parentheses in this step. Last thing you're going to do is you're going to find then the quotient. Here's where we are going to put it all together. After we have found the difference, we're going to divide out the h. Now, typically what's going to happen is you're going to want to factor out an h from the difference that you found in step 2. And then when you factor that h out, then it will be easy to divide the h out of the entire thing because you'll already have an h factored out. So let's walk through this with an example. Here is an example. F of x is equal to negative 2x squared plus x plus 5. So our first step is evaluating f of x plus h, which means for every x in this function, I'm going to replace it with x plus h. Okay, now I want to simplify this. So the only thing that really needs to be simplified here is this x plus h being squared. So remember, that means that that is x plus h times x plus h. And we're going to want to distribute that x plus h times x plus h, which will give us x squared plus 2xh plus h squared. Now remember, you still have this negative 2 out in front, and I'll need to distribute that all the way through. Now notice this x plus h, it was in parentheses earlier. We just dropped the parentheses because all that was in front of it was a plus sign. So I really didn't need to distribute anything more. So go ahead and distribute this negative 2 through. And you would end up with negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Now after you have done all this, you're going to take a look and see, are there any like terms that can be combined? And if we look at each of these terms, let's see, are there any other x squareds? Nope. Are there any other xh terms? Nope. How about h squared? Nada. Are there any other x terms? Afraid not. And how about h or constant? And neither one of those occur more than once either. So each of these are unique types of terms. So we don't actually combine them at all. So we're done with step 1. We have found f of x plus h. Now what we're going to do is we're going to take that f of x plus h and subtract from it f of x. We're going to subtract this negative 2x squared plus x plus 5. So let's do that. F of x plus h minus f of x will look like this. Now I've color-coded this so you can kind of see the different parts. f of x plus h is all in orange here, and that's what we did right here. And f of x is what we were given as our original function. Notice both of the functions are written with parentheses, so we make sure that we don't make sign errors by not distributing negatives through. Okay, so first thing we're going to do is get rid of those parentheses, which in this first case, this f of x plus h, there's nothing in front of the parentheses, so they can just be dropped. But this second set of parentheses, I will need to distribute this negative all the way through as I drop my parentheses. So when I do that, that negative 2x squared becomes positive 2x squared, the positive x becomes negative x, and the positive 5 becomes negative 5. And now I'm going to look through the resulting expression and see, are there any terms that can be combined? So let's start at the beginning. Are there any other x squareds that I can combine with negative 2x squared? Oh, here's a positive 2x squared. That's handy because that means they'll just go away. How about the xh term? No, nothing to combine there. How about h squared? Nope, nothing to combine there. How about x? Are there any other terms that just have a variable x? Oh, there's a negative x here. When I combine those, they just disappear. H? Nope. But 5 has a negative 5 counterpart, and that will subtract to 0 as well. So this negative 2x squared, this positive x, and this positive 5 are all negated by what's in the back by this f of x. So what results when I combine like terms are just these three terms, negative 4xh minus 2h squared plus h. Okay, so now we've completed step 2. We've found the difference for the difference quotient. Now the last thing we're going to do is actually divide out the h. So we're going to take our result here and put it over the top of h. Now this numerator, which is our difference, we're going to write in factored form as we factor out an h. So in each of these terms, do you see that there's an h here? We're going to factor that out like a GCF. So when we do that, we get a result that looks like this. And the h is out front. We have a negative 4x minus 2h plus 1, and that's all sitting over h. So now I have an h divided by h, which we know to be 1, and so I can divide those out. And my final result for this difference quotient is negative 4x minus 2h plus 1. So that's the long and short of evaluating a difference quotient for a given function. And if you go through these 3 steps in this order carefully, then you'll be able to do any function in this way. That wraps up our series on the attributes of functions and the analysis of their graphs, and I will see you next time.